Now, class 7 standard, I am going to start with what is the difference between pressure and thrust or pressure and force. As you start learning it, you will learn that force per unit area is called the pressure. So, in this diagram, I have a brick. All of you know the brick has a length of 10 inch, height is 3 inches and the base is 5 inch width. So, at this position, the lower area is 10 into 5, that means 50 square inch. Mind that I am talking in inch. But if we take the different configuration, that means the 10 inch is here, 3 inches is here and 5 inches is the height, then 10 into 3 is 30 square inch. And lastly I place 3 and 5 at the base. So 3 into 5 is 15. So 15 square inch. Now let us find out what is the pressure acting on the ground. Mind that it is acting on the ground. And if the weight is 5 kg, that means the force is 5 kg weight. So when I divide 5 kg weight by 50, then what happens? It becomes 0.1. That means 0.1 kg per square inch. When I divide 30, 5 divided by 30, it becomes 1/6. And when we divide it by 15, then it becomes about 1/3. That means 1/3 kg per square inch. I am talking about kg and inch. Don't get confused. It is to make you understand that in this case we are not making any mixing up with the units. It can be in centimeter, whatever you do, and you see for the same force pressure can be different. But one thing you have to understand, you have heard about the air pressure, isn't it? What is air pressure? Air pressure is something acting everywhere. What is atmospheric pressure? In the book it is given that it is the huge amount of air, about 10 miles or more than that. Air is there, and so the total weight of the air is falling on the ground. So as we have calculated this weight of brick is 5 kg divided by the area. So if it does the same thing, then we will find it is about 1 kg per square centimeter. Remember, now I am talking about centimeter. 1 centimeter, you know how much is 1 centimeter? About the length of your nail. This is 1 centimeter. Don't get confused, centimeter is very small. So in this 1 square centimeter, if I put it here, 1 kg of the atmospheric weight is falling. So we call the atmospheric pressure is 1 kg. And it is everywhere same at this level. If I take this syringe, you know a syringe is, what is a syringe? That there is a piston and there is a hole, and if I put the piston, all these things are open, so from this air pressure can act. And now little bit air is here. So if I close it and hold the syringe like that, and if you pull it, it's very difficult to pull because the pressure is reducing, and oh my God, there is a mark on my finger. If I pull it totally, then maybe some blood will come out. Many times it has happened. So what happened? The pressure is acting through this. Is it acting in this direction? No. Because if I hold it like this, same thing will happen. If I hold it like this, same thing will happen. That means pressure is everywhere same. But when I am placing it in this direction, this is the area of the piston on which the pressure is acting. So pressure multiplied by the area gives you the force. So that is the force due to pressure. This is very important. When question comes, you write pressure is a scalar quantity. But when we do this kind of experiment, or there is a experiment, we have a glass, some water, we can overturn the water, then water will not fall, and we say pressure is acting in this direction. In fact, sometimes we also make the same mistake. The pressure is acting in this direction. I say the syringe in this pressure is acting this direction, pressure is acting downward, pressure is acting up. All these things are not correct. Because the force which is acting on the piston is the area of the piston multiplied the value of the pressure, which is 1 kg per square centimeter. We can clearly understand. So, if there is no piston, nothing here, pressure is acting in this direction, then what is the force? Nothing. Because if your imaginary plane is there, then if the area is something A, then P into A both are equal, they are cancelling. So, you cannot realize a force normally except for the magnetic and electrostatic force. Always the force needs a surface. How is that? Let us take a balloon. We can blow the balloon, and there is a very interesting thing. All the children like balloon very much, and even the elder people also like it. Now, balloon is inflated. What is the pressure inside? Is it equal to atmospheric pressure or it is more than that? I have blown forcefully air inside that, so definitely the pressure inside will be more than the atmospheric pressure. Now, pressure will be everywhere same. But now, what is the force due to pressure? That is a very interesting question. Force, if the force has to act, it has to some area. That means this air pressure, from outside the air pressure, if I say this is 1 centimeter square, then force is acting in this direction. Then why it is not going down? Because from inside also same force is there. That means in this balloon, force is acting in this direction, force is acting in this direction, force is acting, or everywhere force is in different direction. And when we will go in higher class, you will know that force is a vector quantity. That means it has a direction. So if it is in different direction, this balloon has the same pressure but different force. Even that the per square centimeter the force may be same, but there the force which is acting on the surface is not at the center of the balloon. Then if I remove my hand from here, what will happen? All of us know this goes in this direction. If I put my hand here, it's stationary. What is this? Why it is stationary? And people will say the air is coming out and pushing this air. Okay, there is another theory. I think many of you know this theory, that if I fold this, nicely I have to fold it, this paper, and also this is slightly not okay. Now I put this here. So it's like a bench. If I give a blow from over here, by here, what happens? It goes down. And if I blow from down, it will definitely go out. Let me remove my hand so that let me try some way that it remains like this. Okay, now I am going to blow through this. Again going down. Why it is so? There is a principle called Bernoulli's principle, which says that if air moves in a faster way, if there is a flow of air which has higher velocity, then the pressure becomes lower and outside pressure is higher, so it pulls it down. So now, nobody has said it before, I am telling you. Now, somebody tells it is the Bernoulli's theory. So when air is coming out with a high force, why high force? Because this membrane is trying to collapse and it gives elastic force on the air, so air moves at a high speed. So what will happen? There will be low pressure. If there is a low pressure, then this pressure will push it in that way. No, it doesn't happen. It happens that it goes in the other direction. And when I release it, if I release it like this, it will remain there. Why? Because this force is absent now. When it is like this force is absent, so only this force is acting. That is why a balloon goes in this direction. So now you understand force is a directed quantity, which is force per unit area, which acts all through this balloon, and pressure is everywhere same in this balloon, which is its magnitude only. It doesn't have any direction. Pressure acting, I should not say pressure is everywhere same, in the same level. Now, so this experiment is something you should remember and do it, and it can be a fun to you also. By using a balloon, we get so much good concept.